This is Chemistry for Grade 11, produced by Tigray Education Bureau, transmitted by Dimtsi Weyane Tigray National and FM radio satellites and social media, and also FM Maqala 104.4.
Hello students, this is chemistry lesson for grade 11, presented by Untitled Chapter. Students, today you will learn about the subtopic chemical bonding theory in covalent bonding. Students, at the end of the lesson, you will be able to name two chemical bonding theories, explain the valence bond theory, distinguish the Lewis model and valence bond model, explain hybridization, predict the geometrical shapes of simple molecules on the basis of hybridization. Alright, before we discuss about chemical bonding theory, I will ask you two questions and please try to answer them. Listen carefully. Question number 1. What is covalent bonding? What is covalent bonding? Question number 2. How a covalent bond is formed? How a covalent bond is formed? Students, did you answer the questions? Good. Let me provide you the correct answers. The answer for question number 1 is a covalent bond is a chemical bond that binds particles together in covalent compounds. It is also known as molecular bond. The answer for question number 2 is a covalent bond arises by sharing of electron or electrons. Students, is that clear? Good. If it is clear, let me proceed to the chemical bonding theory. A chemical bonding theory was developed to explain the process of covalent bonding. This theory consists of the valence bond theory and the molecular orbital theory. Today, we will discuss only about valence bond theory. It was developed to use the methods of quantum mechanics for explain covalent bonding. It focuses on how the atomic orbitals combine to give individual covalent bonds. Basically, a valence bond theory focuses on overlapping of atomic orbitals to give individual covalent bonds. According to valence bond theory, an overlapping region is between nuclei of atoms. It is occupied by shared electron pairs. It is a region of high electron density. Overlapping happens only by half-filled atomic orbitals. For each overlapping, there is an optimal overlap that leads to maximum bond strengths at particular internuclear distance. Bear in mind, the maximum bond strength is bond energy, whereas the internuclear distance is bond length. There are a lot of overlapping types. The most common are SS orbitals overlap, SP orbitals overlap, and PP orbitals overlap. Students, let us see examples. Example 1. In hydrogen molecule, the single bond between hydrogen atoms arises when 1s1 orbital from the first hydrogen atom overlap with 1s1 orbital of the second hydrogen atom. Therefore, the type of overlapping is SS overlap. Example 2. In hydrogen fluoride molecule, the single bond between hydrogen and fluorine atoms arises when 1s1 orbital of hydrogen atom overlaps with 2p5 orbital of fluorine atom. Therefore, the type of overlapping is sp overlap. Example 3. In carbon dioxide molecule, each double bonds between carbon and oxygen atoms arise when 2p2 orbital of carbon atom overlap with each 2p4 orbitals of oxygen atoms. Therefore, the overlapping type is pp overlap. Students, is that clear? Okay, if it is clear, let me proceed to the next point, which is ways or modes of overlapping. According to valence bond theory, there are two possible ways of overlapping between atomic orbitals. These are linear or end-to-end overlapping and lateral or side-to-side overlap. Good. Let us see them one by one. Linear or end-to-end overlapping is also known as head-to-head overlapping. It results in sigma type of covalent bonds. Its highest electron density is along the bond axis, where bond axis is an imaginary line that joins the nuclei. SS and SCP types of overlapping are linear. All single bonds are sigma bond. The lateral or side-to-side overlapping is also known as parallel overlapping. It results in both sigma and pi types of covalent bonds. Unlike two linear overlapping, it has two regions of electron density which occurs one above and one below the sigma axis. This implies that each electron pair occupies a distinct region, but both regions considered as one electron set. PP type of overlapping are lateral. A double bond has one sigma and one pi type of bonds, but a triple bond has one sigma and two pi type of bonds. Students, is there any ambiguity? Good. In order to make it clear, let us see an example. Example. Find the total number of sigma bonds and pi bonds present in hydrogen cyanide. Since the correct Lewis structure of hydrogen cyanide is hydrogen single bond carbon, carbon triple bond nitrogen, then it has two sigma and two pi bonds. Is it clear now? Good. If it is clear, please do exercise 3.12 from your textbook, which is written on page 168. Let's proceed to hybridization. According to valence bond theory, orbital hybridization is the mixing of atomic orbitals to explain covalent bond formation. It is a mixing of atomic orbitals, mostly s orbitals, p orbitals, and d orbitals, to form new hybrid orbitals. The new hybrid orbitals have different energies and shapes than atomic orbitals. For every hybridization, total number of new hybrid orbitals is equal to total number of overlapped atomic orbitals. Hybridization provides a convenient method to predict molecular shapes, but it doesn't explain the reason for the overlapping. Students, the number of half-filled new orbitals called hybrid orbitals is determined by using the number of electron sets or sets for any given molecule. The general steps which helps you to write the hybridization of any molecule are: Step 1. Write the possible Lewis structure. Step 2. Use the valence shell electron pair repulsion theory to predict the electron set arrangement. Step 3. Select the hybridization scheme that corresponds to valence shell electron pair repulsion prediction. The last step is describe the orbital overlap. I will repeat it. The general steps which helps you to write the hybridization of any molecule are: step 1, write the possible Lewis structure. Step 2, use the valence shell electron pair repulsion theory to predict the electron set arrangement. Step 3, select the hybridization scheme that corresponds to valence shell electron pair repulsion prediction. The last step is describe the orbital overlap. Example: for nitrogen molecule, find its number of hybrid orbitals and write its molecular shape. It is known that there is only a triple bond which binds nitrogen atoms in nitrogen molecule. Therefore, nitrogen molecule has one electron set. As a result, the hybridization of all molecules with one electron set is SCP. And obviously, the molecular shape of all molecules with SCP hybridization is linear. Therefore, nitrogen molecule has SCP type of hybridization and linear molecular shape. Students, is that clear? If it is clear, write the hybridization type and molecular shape of phosphorus pentachloride according to the above example. Students, did you answer the question? Okay, let us see the correct answer together. Since phosphorus pentachloride or PCl5 has 5 electron sets, then its hybridization is sp3d. This means there are totally 5 hybrid orbitals, specifically 1 from S subshell, 3 from P subshell, and 1 from D subshell. The molecular shape of phosphorus pentachloride is trigonal bipyramid because molecules with 5 electron sets and sp3d types of hybridization provides mostly trigonal bipyramid molecular shape. Let us see an additional example. Sulfur trioxide or SO3 has 3 electron sets or 3 electron set arrangement. Then its hybridization is SCP2. As a result, the molecular shape of sulfur trioxide must be trigonal planar. Students, now let's summarize the main points of the lesson. A valence bond theory focuses on overlapping of atomic orbitals to form a covalent bond. Overlapping process takes place at the region between nuclei of atoms. As overlapping process increases, the electron density also expected to be increased. SS, SCP, and PP are the most common types of overlapping. All end-to-end ways of overlapping gives sigma type of covalent bonds. Side-to-side ways of overlapping gives both sigma and pi types of covalent bonds. Hybridization is the mixing or blending of atomic orbitals to form new hybrid orbitals. The common types of hybridizations are SCP, SCP2, SCP3, SCP3D, and sp3d2. Hybridization provides you a convenient method to predict molecular shapes. Molecules with equal electron sets have the same types of hybridization, but may have different molecular shapes. Students, write a short note from your textbook starting from page 162 up to 180 and do all the exercises inside it. Our next lesson will be the molecular orbital theory in covalent bonding and metallic bonding. Until that, goodbye.